Hi there. So I'm here to talk to you about moving beyond riparian fencing, so partnering with ecosystem scaling with ecosystem services with society to achieve in-stream restoration. And just to start off with a quick apology from Catherine February, who's the person who submitted this abstract and isn't able to be here today, so I'm just presenting our research on her behalf. So a quick outline of where I'm going with my talk today. So talking about what is CAREX, talking about multiple stresses at multiple scales, talking about scaling solutions for macrophytes for aquatic weeds, and working together to achieve successes. So everyone goes into their restoration project with the best of intentions. However, there's a large body of literature around why restoration projects fail. And so this is around issues with goal setting, so either goals aren't set or the goals that are set are so vague that progress against them can't be measured. Looking at implementation, so a plan's been developed but maybe it's not necessarily followed. A failure to address multiple stresses in the system, failure to take into account local context, and a lack of monitoring of progress on any goals if they were set. And these all result in an unrealistic expectation of the success of projects and can lead to the failure of projects. So, in our studies in Canterbury, what we have come to the realisation is that the local context, so the people in place, really matter in terms of restoration success. And so we have come up with this CAREX project, which stands for the Canterbury Waterway Rehabilitation Experiment, where we're working with 23 landowners across 9 kilometres of stream and their 14 working farms. And so what we're doing at these sites is working with the stakeholders, the people who have vested interests and work in these locations to evaluate these tools, applying them at varying scales to achieve restoration. So, a little bit of context. The Canterbury region was a vast wetland, and over the last 150 years it's been gradually and progressively drained. Most of the streams that we see now they're modified drains. The region is in long-term intensive agriculture. Riparian fencing is the main tool that's applied to address the issues surrounding this intensification on the aquatic environment, and if planting occurs, only a small buffer is usually available for planting, and it's constrained by the fact that these pivot irrigators pass over at 2 metres height, so anything has to fit within that. And so because of all this, there are some issues that we are seeing in our research that are faced by these drains. So high nutrients, high N&P levels, excessive macrophyte growth, so these aquatic plants, high sediment, high fecal bacteria, and resulting in low biodiversity. So when we're undertaking our studies in these streams, there are 3 scales that we are measuring these stresses and then responding. The first one is at the stream level. So like I said before, we have these 9 sites that we're working at. They're all 1 kilometre long. Within that, we have reaches, which we've defined as about a 20-metre reach within our greater study system that we're focusing some effort. And then within that, we have at the finer scale, less than 2 metres quadrats or serber samples that we are evaluating what's going on. And from our research up until now, we've discovered that the different stresses that we study, they vary at the different scales. So, for example, sediment, we're finding variation at the very smallest scale, at the quadrat level. We're finding macrophytes and nutrients have great variation at the reach level, and biodiversity is at the stream scale. Probably that's unsurprising. From here, I'm going to just talk about scaling solutions for the macrophyte part of the project. So macrophytes are these aquatic plants that inhabit these drains, and they do have some really important functions in the streams. So they import organic matter into the streams, they provide habitat for the fish and invertebrates, they photosynthesize and respire, so play some role in oxygen cycling in the streams, and also have a role in nutrient cycling. However, in these streams, underneath this massive mat of macrophytes, you can see there's a stream that is flowing in here, And so during the summer months, the growth of these plants is just so prolific that the stream ceases to drain, ceases its function, and sediment that's entrained in the water can become deposited in the stream. The drainage function is lost, which can result in flooding of the adjacent productive farmland, and so management is put in place to restore this function. And here's a picture of what the most common method of this solution is in our Canterbury drains. So it's a bank-based excavator with a scoop bucket that comes along and removes the macrophytes, and unsurprisingly that has some ecological effects. So it can result in the banks of the stream becoming hugely oversteepened. Any fish or invertebrates that are living on the macrophytes can be removed, or if they're lucky enough to remain in the stream, their habitat that they were living on is lost. The sediment that these macrophytes have been trapping is now entrained, it's disturbed, and it can flow back out to sea. The succession of these plants is reset, so we think that the disturbance that this solution is having is actually probably resulting in increased macrophyte growth by resetting the system. And the macrophytes can grow from their fragments, so by digging them out and letting some float down in the flow, we're actually releasing those fragments further downstream. So the purpose of my part of the project and what my PhD is focusing in within the CAREX project is looking at finding alternative solutions to that type of management of macrophytes. And I'm doing that with an experimental approach looking at different scales. So I started off with a small scale trial and then scaled things up to look at shade intensity and then further to reach scale trials. So just quickly to talk you through those. So here in the small scale trial, I had 8 different treatments. You can see here a weed mat treatment and here a shading treatment that were along this 200 metre reach of stream where we tested our different treatments. Then we found that some level of shading is effective at controlling these macrophytes, and so here what we're trying to establish is what the pattern of the plant growth is across a gradient of shading using different levels of commercial shade cloth, and to find out if there's some sort of threshold that beyond which macrophytes are unable to grow. And then some reach scale trials, so scaling up herbicide spray. These are all treatments that we found to be effective at the small scale, and scaling them up to see whether the same sort of patterns in responses is what is seen at the larger scale. So using herbicide spray, large scale hand weeding, suspending polythene as above the surface of the water as shading, and using weed mat. And so from all of this, we've showed that actually there are improved options that could be used to control these weeds. There is some level of shading will control these plants. The weed mat, polythene and spraying are effective in the short term, and combined with the riparian planting, they can then work to achieve some sort of long-term control of the macrophytes. And then coming back to the third thing I said I was going to tell you about working together to achieve success, this is an example of one of our sites where I had my small-scale macrophyte control experiment. This is the Silverstream site, which is in the Te Waihora Lake Ellesmere catchment, and the landowners of this site are passionate conservationists. You can see this wetland up here. It was set aside about 20 years ago as a Kiwi2 covenant, and they've been working on replanting and controlling pest plants within there for a number of years. The site it's a part of the Living Water Doc Fonterra partnership. It's one of Te Waihora is one of the sites, so we're working with Doc and Fonterra on what we're doing at the site, and a number of other partners you'll see that we have listed down here, including the ESR, who are looking at fecal source tracking within the wetland, and all the other people who are contributing. And to give you an example of how we see our successes working together, so this is a picture of the headwater waterway here before we did anything. You can see there's a whole lot of macrophytes growing in this stream. There's our hawthorn hedge, which actually had become quite undercut underneath the hedge and was a source of sediment. So what we did is we got a digger in and we ripped out this hedge, and then we had some bank reshaping. So this was to address the sources of sediment from the undercut bank with the hedge, and big chunks of the bank were just falling in and washing out. So we've rebatted the slope to a more suitable gradient. Then we had this community planting day where local schools and local iwi and interested parties came out and helped us with establishing these CAREX plants down the reach. And then we've put the fences back in, which are set back slightly further than the original fences were, and we also had some specimen plants planted on the left-hand bank there. And then this is kind of reviewing our progress with Richard and Jill, looking at their perspectives on the waterway and how they're feeling. This is looking at the site 1 year on, so you can see that the plants are starting to grow up. And then 2 years on, it's actually starting to look like a pretty well-established planting. We've also added habitat in this reach of stream, so here you can see some boulders and some logs that were established, and that's about this habitat was lacking from the stream, and you can see on this photo of the stone that we've turned over the number of snails and the different eggs of invertebrates and fish that are now on the bottom of the stream, just proving that if we've added this habitat and actually it was something that is really lacking, and the biota in the stream are appreciative of that. We've also been putting in sediment traps in this waterway, so the theory here is basically we're digging a hole in the stream, and as you can see here, our stream coming through, the hole that we've dug in here becomes, the water velocity in there is greatly slowed, and the sediment that's entrained in the water is dropped out, and so then flowing out, you can see that actually there's some gravel that's exposed below our sediment trap, and so we're containing the sediment within this hole that we've dug, and we can come along and maybe a year later or once it's filled up, remove that sediment to address the problem. And so we found that to be 70% effective at removing the fine sediment within the stream. And also we've now got this living classroom. We have a number of school groups, Māori high school outreach. We've had Radio New Zealand out there and had interviews with the landowner and the various partners working on the stream. And we have a best practice site on the ground that we can take ECAN or landowners or other interested parties to have a look at what we've been doing. So I guess moving beyond fencing, what we're saying is moving into the stream to achieve the restoration, but also moving beyond fencing in terms of working with people to find context-specific solutions. So applying our multiple tools at the scale that is appropriate to address the problem, and matching that to the local context, the issues at the place. The strong realisation that these systems are socio-ecological, so that the solutions need to be co-developed with the people who are living and working and breathing these systems. There's no point in us sitting in our ivory tower coming up with solutions. It's not actually going to help. And obviously, from what we've been hearing through today, this is a national issue, and so the kind of next stage of where we're going to with the project is looking at scaling context-specific solutions across the whole of the country rather than just focusing on our 9 waterways in Canterbury. So obviously this is a large piece of work that's been happening with funding from a number of people over a number of years, and so just to thank all those people who've been involved.